show you a nifty little thing. I actually did come to figure out how you can do this on a calculator. So I want to show you how to do all those little intricate details and intricate computations with your calculator so that you don't have to run the risk of making all the mistakes. Okay, so here we go. We'll start with this. This is the problem where I make a profit and off of the card game. Okay, so I'm either making $5 or no dollars or -5, I'm losing 5, or I'm losing 95. Now, I want to show you how you can get your calculator to compute the mean and the standard deviation with itself without you having to do all of the little intricate pieces yourself. So you need to go to Stat, Edit. Okay, and in list 1, I want you to put all of those profits. The $5 to 0, -5, and -95. Okay, so in your list 1, put those profits. Alright. Then in list 2, you're going to put the frequency that those profits occur. Alright, so $5 occurs 36 out of 52% of the time. So I did down here 36 over 52. I hit enter and then that percent, that decimal comes out. Okay? So that's how frequently I make that profit. And then the next one is 12 out of 52% of the time. 3 out of 52 and 1 out of 52. So list 2 contains how frequently those profits in list 1 occur. Alright, so now you're going to go to Stat and calculate the one variable statistics. Alright, so I hit one variable statistics. If your calculator has Stat Wizard, then this shows up. Okay, if it doesn't, then just hold on for a second. I'll get to what yours looks like. If your calculator has Stat Wizard, then you will have the list 1, and the frequency you need to put in L2. So go second 2 right there. Okay, so that will give you list 1 with L2's frequency, and then when you calculate that, you get the values that we so painstakingly got yesterday. The mean is X bar. The mean of X is X bar. X bar is the mean of X. 1.35 is the average profit that I would make. Yes.
Mine didn't like do the 2 lines. You have to do the L2.
Okay, so if yours does not do the 2 lines, hold on a second. That you don't have the Stat Wizard on, and so I'll show you that. So hold on a second. And then see your standard deviation is down here at 13.8. All right, now let me show you. If you do not have the Stat Wizard, what yours looks like. So let me turn mine off. Okay. So if yours does not have the Stat Wizard, then you get this. You just have one variable stats show up. And so what you have to do is you have to tell it to specifically compute list 1, comma, which is above the 7. List 2's, so second 1, comma, second 2. And if you do not do that, then you're only going to get information from list 1. It's list 1 with list 2's frequency. You hit enter and then it does the same thing. Okay? So that's a big old woohoo! Ta-da! Yay! We can have the calculator do that for us, and then we're not making all those little bitty mistakes that can happen when you're typing in a huge whole bunch of numbers. Okay? Alright, so that's the nifty little thing for today. Now, we need to learn what goal number 4 is and goal number 5 is and practice those. And so let's do that. So turn the page to number 4. What page in your packet is this one, by the way? 34 in your packet? 31. Okay, 31 is the notes part of it, and then the homework of it would be probably 34. Okay, so here we go. Goal number 4. We want to know what happens when you transform data. When when you need to add or subtract or multiply or divide, what's going to happen to the mean and what's going to happen to the standard deviation going through that transformation? This is not new. This is total review. We have done this exact same thing before, so you should remember that. When your data goes through a transformation, the mean is affected by add, subtract, multiply, and divide. The center, mean and median, are affected by all the operations, and remember that standard deviation is only affected by the multiplication and division. Okay, you remember that? A visual of it is here. If I just take this and I shift it, meaning I add it or I subtract it, then it's just going to change the center. The spread will not change. But what happens if I take it and I multiply it, meaning I like double it or quadruple it? What things will change? If I multiply, what's going to happen? Does the center change? If I multiply, what changes? The center. Does the spread of this picture change? Yes. Multiplication changes center and spread. Addition and subtraction only changes the center. Okay, so real quick though, a little song for that is when the data that you have goes through a transformation. Okay. Addition and subtract, addition and subtract, addition and subtract affects the center only. Affects the center only. So addition and subtraction only affects the mean. Addition and subtraction does not affect the standard deviation. Okay? Multiplication affects them all. Okay, so let's do some problems here. So, Joe's Pizza and Pasta leased a commercial grade washer for the restaurant for 4 years, and the expected number of repairs the Samsung dishwasher has is 0.45 per year. How can you have 0.45 repairs a year? That's on average. Very good. That's an average. So this is not for real per year. Okay, expected number. I can write this. Mean of repairs is 0.45. All right? The standard deviation for that same period is 0.6. So the standard deviation for the repairs is 0.6. Now, this company wants to know, okay, how much is that going to cost me? Joe's Pizza and Pasta needs to budget for their repairs costs in a year. So they know that the cost of the service contract for the dishwasher for unlimited repairs is $110 a year plus $6 service charge for each repair. All right, so that is, the cost is $110 plus $65 per repair. That's the function. That's the transformation that's going to occur. This is the transformation that's going to turn repairs into money, repairs into the cost. All right, so let's find the mean cost and the standard deviation for cost. All right, so the mean cost is going to be 110 plus 65 times the mean number of repairs, which is 0.45. That is 139.25. Now, I plugged that in to the entire equation. Why did I allow 110 and 65 to both be affecting the mean? Because what? Good. All the transformations affect the mean. Add, subtract, multiply, and divide. All subtract the mean. All affect the mean. Okay? All right. How about our standard deviation of cost of 0.6? What's going to affect our standard deviation? Just the multiplication part of this function. So what's that going to be? This 65 times the standard deviation number of repairs, and that comes out to a standard deviation cost of $39. So we transformed from number of repairs into cost. And there we go. All right. So let's see. Let's do that problem on the homework. Chapter 16, Part 1. I think that's number 4 this year in the packet. So, or number 34. Right after the ones you did yesterday. Let's see here. Okay. It's a problem about my, let's see, what is this? My allowance that I used to make when I was little. Okay? So, when I was little, every Saturday, I would get my allowance. And so there was a 20% chance that I'd get $1. Okay, and there's a 40% chance that I'd get $2. And then there's a 40% chance that I'd get $4. So essentially that would be the table. The money is $1, $2, or $4, and the probabilities are there below. So if you did the little formula, 1 times 0.2 plus 2 times 0.4 plus 4 times 0.4, you get the expected allowance of $2.60 every Saturday. That's what I could expect to happen. Now, question A says, would I ever actually get that expected allowance? Would my parents actually be handing me $2.60? Why not? Good. Because $2.60 is the average, it's not the actual that occurs. The numbers 1, 2, and 4 are the numbers that actually occur. 260 is an average. All right. Okay. Now, the standard deviation, by the way, if you had done the computation for that, it is $1.44. Okay. Some Saturday afternoons, I'd go to my grandma Podsednik's house, and she'd give me $3. Okay, so that's my real grandmother. My mom's mom, Czech, you know, west, I-35 down to Austin, the Czech stop, all that kind of stuff, that's where they're from. So my grandma grew up there. Grandma Podsednik would give me $3. So what is the expected allowance and standard deviation on Saturdays that I would go to my grandma Podsednik's? Okay, so how am I going to figure that out? Meaning in addition to what my parents gave me. Okay? If I wrote E, what am I meaning there? That's expected. What else could I put there instead of that E? I could also put the mean. The mean and the expected value are the same thing, okay? So get used to that. Anytime it says expected or mean, those mean the same thing. All right, so the expected allowance that I get from my parents plus my grandmother Podsednik is how much? What do I do for means? So what can I do to that? Actually, I think I should put a 3 here, because that's what my grandmother's going to give me. So I take what my parents, on average, what my parents are giving me, and I add the constant 3. So how do I compute that? You just add them. Very good. So my expected from parents plus 3 means that on average, the Saturdays that I go to my grandma Podsednik's, I expect on average to get $5.60. Okay? With what standard deviation? So I'll put the standard deviation of my parents plus 3. And so even though I'm writing in this parents plus 3, what actually happens? Nothing. Plus 3 is addition. That does not change the standard deviation of the distribution. Doesn't change the $1.44. So it will just stay at $1.44. Okay? Addition's not changing it. All right, very good. Next, some Saturday afternoons, I would go to my grandmother Hart's house. Now, actually, this wording is a little different than I intended it, so let me clarify it. It said she'd always double whatever allowance that my mom and dad had given me that morning. What I really intended that to say is she would, she wouldn't give me double. She would give me what my parents gave me. She would duplicate what my parents gave me, so my allowance then doubled. Okay, that's what I mean. My allowance doubled. She would duplicate what my parents gave me. So the expected would essentially then be what? Twice what my parents give me. Okay. Then we'll find the standard deviation of twice what my parents give me. All right. So how's that work? Very good. And so we've got, so I expect on average on the Saturdays I go to my grandmother Hart's to get $5.20. And then on average, what I expect, or not on average, the standard deviation for that would be what? Would it just be the 144? It is not. Because what happens? She is doubling, so that means that it is stretching the distribution. Okay, so then that means it's, so it doubles the standard deviation. It does multiply. Okay. All right, one last one. Only a few times a year I get to go to both my grandmother Podsednik's house and my grandmother Hart's house. So both of those transformations are going to occur. So find the expected allowance and standard deviation for the Saturdays that I get to go to both my grandmother's houses. So this would be the expected value of 2p plus 3. Now, we're not going to say that my grandmother Hart's not going to double the $3 from my grandmother Podsednik. Okay, so we're going to say she doubles what I get from my parents, and then also my grandmother Podsednik gives me $3. All right, so figure that out. So do these two right now, and we'll see what you get. Okay, so the standard deviation for the transformation, even though I say the standard deviation for this transformation, it's still just multiplying by 2. Okay, good. Got that? That's objective 4. That's goal 4. Let's go back to goal 3. Or, sorry, goal 5. So go to your notes. Okay, go back to the notes. I think it's at the, is it the bottom of 31 again? Okay. All right. Here we go. Okay, last thing to learn this chapter. Woohoo! Okay, so the last thing to learn this chapter is what happens if you have 2 means and 2 standard deviations, or, in this case, it's going to be where, say, Joe's Pizza and Pasta has not only a dishwasher repairs, but oven repairs. So I want to add those 2 averages together, and I want to add their standard deviations together. So I am adding means and adding standard deviations. Okay, I'm not just putting it through a function of transformation. I'm adding means and adding standard deviations. So what's the rules on that? Well, guess what? The means behave as you would normally expect them to. you can simply add or subtract the two or more means together. So, no problemo. They're all good to go. Let's go down and do that right here at the bottom. For example, if the repairs for the dishwasher in a year have an average, so the average for the dishwasher is 139.25, which we just figured out above. And the standard deviation for the dishwasher is $39. And the service contract for an oven, so they also are going to do the average for the oven is 115, and the standard deviation for the oven is $27. Okay, so the first question is, what's the expected annual contract or cost for both of those means? So what you're going to get to do? Yep, they just add together. So very good. So my mean for the dishwasher plus the oven is just going to be $139.25 plus $115. And so I expect on average to pay $254.25 per year for those two appliances. So if I'm just pizza and pasta, I know what I'm budgeting, because on average, that's what I'm going to be expecting to pay. All right? Okay. But with what standard deviation? So like how much, plus or minus what? All right. That has a special rule, kind of just how the other standard deviation has a special rule. It gets quite mathy, and I'm not going to go through it all. It actually uses orthogonal vectors and three-dimensional concepts to come up with the formula. But it is essentially the same as how you do Pythagorean's theorem. Okay, so like you do Pythagorean's theorem, you know how you have to say a squared plus b squared equals c squared. Well, this is going to be the same. If I take the standard deviation of one of the items, square it, and the standard deviation of the other item, and I square it, it'll equal their sum squared. And then what do I need to do to get it down to just this standard deviation? Square root it. So therefore, to get the standard deviation of them combined, one of them squared plus the other one squared. Okay? So there you go. You just have to remember Pythagorean theorem of statistics for the standard deviation. It's special rule. You can't just add them. That makes it too much. So let's do that down here. Find the combined standard deviation for the dishwasher and the oven. It is not just 39 plus 27. That would be too big of a standard deviation. So, the standard deviation for the dishwasher plus the oven is going to be the square root of 39 squared plus 27 squared, and that's, I think, 4743. See how that's not as big as them just adding straight together? Adding the standard deviations together is too much. Okay, one little other thing. Let me just ask you, how much more is the contract or the cost annually for the dishwasher? How much more is the dishwasher than the oven on average? How are you going to figure that one out? Subtract it. Very good. Okay, so let's kind of do another little thing because you're going to have it on your assignment. So let's do how much more. So the average for the dishwasher minus the oven. Can I just straight up subtract their means? Is that allowed? Yes, means is allowed. So 139.25 minus the 115. So what is it going to be? 24.25. Okay. So that dishwasher's costing me that much more per year on average. With what standard deviation? This is the catch. This is the thing. Standard deviation, remember, is the little special Pythagorean theorem thing. Standard deviation is the special. But guess what? Not only is it special in that you have to do the Pythagorean theorem, do you ever subtract during the Pythagorean theorem? No. That's the thing. So even if I'm finding the difference between the two standard deviations, the Pythagorean theorem has still got addition in there. Okay? Because you can't get less varied. If I have something and I don't know, and then I take away and I'm not sure how much I took away, I'm still more uncertain. So guess what? The standard deviation for the dishwasher minus the oven is this right here. It's still this same operation as above. So the difference between them has the same standard deviation as the sum of them. Is that too much in your brain? You got that down? Okay, that is all the rules in this chapter. So if you then go over here to finish out your homework, chapter 16, part 1, the last page, page 35, the last problem, goal number 5, it's about the allowances again. And so we're going to add in another distribution. We're going to add in my brother's allowances and see what all my parents are having to pay out for both of our allowances. So my older brother, James, since he is older, his allowance is larger because he had more chores, so his allowance had an expected value of $5.20. So the expected for James is every week was $5.20 with a standard deviation for his allowance of $2. All right, from the previous page, my allowance is still the $2.60, and the standard deviation of my allowance is $1.40. So I want you to go through these 4 problems right here and see how you do. Okay, follow those right there, and I'll give you the answer here shortly. Yeah, it is. Yep. And my grandmothers have Fednick and Hartz. So now you know my maiden name. And my mother's maiden name. Oh, that's a lot of security questions on, like, the computer and stuff. Seriously.
Whatever.
Then how do you remember it?
If it asks you for your pet's first name, you're not supposed to actually put your pet's first name. It's really easy for hackers to find that stuff out. You're supposed to put like
Pet's
something
name are you
random and
gonna
write it
put?
down with your mouse.
Did you make your internet grid?
Well, you know, Joe's probably pretty knowledgeable about all that stuff, so I'd probably be pretty scared. The homework is chapter 16, part 2. All right, now, we haven't done the extension problems. I've kind of changed the order of this around because I've made it such that we have like 20 minutes in class to do work. So I've kind of spread it out a little bit. So these problems I need you to not do yet because we're going to learn the extension problems Monday. So do not do on the homework 11E, 12C, 13C, or 14C. We'll do those on Monday. All right, and then your quiz is Tuesday. So because of my absence last Tuesday, everything kind of got pushed back a day. I'll go ahead. I don't have those. Here's you some answers if you want to check your chapter 16 part 1. I'm going to come around shortly and stamp this. I want to see the work to get these answers here. I'm stamping your pages 33, 34, and 35. Okay, stamping 33, 34, and 35. I'm not wrong. These are right. These are right. You are wrong. Okay. Got that?